Hello. Today we're going to talk about the area of trapezoids and parallelograms, which are considered special quadrilaterals. Yesterday we talked about the area of triangles and the area of rectangles. Please remember that when you're finding the area of a rectangle, you're doing either the length times the width, or we call it the base times the height. When you're finding the area of a triangle, because that's half of a rectangle, it is base times height divided by 2. Please remember that anytime you're doing area, you're doing units squared. So it's either centimeters squared, feet squared, yards squared, miles squared, anything, whatever the unit is, squared. When we're talking about quadrilaterals, like I said, we're talking about four-sided figures. So a square would be a four-sided figure or quadrilateral. A parallelogram is a four-sided figure or quadrilateral. Rectangles or trapezoids are all four-sided quadrilaterals. The first one we're going to talk about is the area of a parallelogram. Parallelogram. A parallelogram is a four-sided figure that has two congruent sides opposite each other that are going parallel. When we are doing the area of a parallelogram, we are going to find the product of the base and corresponding height. Or simply put, you're looking at area equals base times height, which was the same one of the versions of formula that we did for a rectangle, because you're going to find that a rectangle and a parallelogram are very much alike. So what I'm going to do now is I'm going to actually draw a parallelogram. I'm going to make my parallelogram 6 across, then I'm going to go down 4 over 2 and go 6. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, I did 7. There we go. There. So I've created my parallelogram. You'll notice this side is congruent to this side is congruent to this side. Now, the base in this case, we're going to say that it is 10 centimeters. So the distance from here to here, this vertex to this vertex, is going to be 10 centimeters. And now I'm going to create a height. Now, it's difficult when we have a parallelogram because we don't have a straight side length. So oftentimes what they do is they will take where this vertice is here, they will draw, or an angle here, they will go straight down and create a right angle, and this will create our height. Your height has to come from the base up to the vertex of vertice up here. And so in this case, we're going to say that this is 6 centimeters. Now, I'm going to highlight this as our original parallelogram, but I want to show you how this relates so much to a rectangle. And I want you to imagine with me, if I were to take, so here's my parallelogram, and I want you to pretend that I took this triangle, and if I move this triangle right here, so now I've taken my triangle, I've pushed it out over here. What shape have I now created? Class?
Square. Rectangle.
A rectangle. Remember, a square has 4 sides that are the same. A rectangle has 2 sides that are the same and 2 sides that are the same. Alright, so now using our formula that I gave you, area equals base times height. In this situation, The base is given to you. It is 10 centimeters. So area would equal 10 times the height, which we said was 6 centimeters. 10 times 6 is what, class?
60.
Thank you.
60.
What is our unit, class?
10 centimeters.
Our unit is centimeters.
Centimeters.
Good. And it's not just centimeters, it's centimeters squared because we're talking area. And that's all you have to do. So the space inside this parallelogram is 60 centimeters square. All right, so now we're going to do our next example, or our next practice part, which is finding the area of a trapezoid. Now, a trapezoid is also a four-sided, four angles. It's similar in that sense. It's a quadrilateral. However, our side lengths are different, and our angles are different. So there's four sides, but they're not the same length. So I'm going to draw one in a second, but right now let's write down the definition or the formula for the area of a trapezoid. It would be the sum, so we're going to add something, of base 1 and base 2. So we're going to add the base 1 and base 2, and you'll see what that is in just a second. Multiplied by the height divided by 2. And that seems very wordy. I'm going to show you the formula, and then we're going to actually put it into use. So area equals base 1 plus base 2 in parentheses times the height divided by 2. So now let's draw a parallelogram. A trapezoid. So I'm going to have now this is not to model or to scale, so it's not a perfect example because I didn't actually measure things out to make sure it was to scale, but it gives you an idea. So we're going to draw an example trapezoid. You'll notice that this side and this side is parallel. So a trapezoid has two sides that are parallel, but you'll notice that the length of all of our sides is different. So as long as the four sides and two of those sides are parallel, you're good. Okay, so this is going to be 10 centimeters. This is going to be base 1. This is going to be 20 centimeters, and it's going to be considered base 2. So this final piece that I need in order to be able to use the formula is I need to have a height represented. In order to have a height, you're going to create a line that goes from base 1 to base 2, and it's going to be a line that is perpendicular, so you're going to have right angles. So I've created my height connecting base 1 and base 2, and this is going to be, we're going to call this 5 centimeters. So now I have all of my measurements that I need. Now I can plug in the formula. Area equals base 1 plus base 2 times the height divided by 2. Now let's plug in our values. Base 1. What is base 1, class?
10
centimeters. Centimeters, good. Okay, we're going to add base 2. What's base 2?
20 centimeters.
Now, I typically make this base 1 and base 2, but it really doesn't matter. As long as you're just adding the two parallel lines together, that counts. And we're going to multiply that times the height. What is the height?
5 centimeters.
And then we're going to divide it by 2. So we have 10 plus 20 times 5 divided by 2. So now we're going to do order of operations. Starting first within the parentheses. 10 plus 20 is what, Renfairy?
30.
Thank you. We're going to multiply that times 5, divide by 2. Now we're going to multiply the 30 times 5. What is 30 times 5? Jose? 30 times 5. What is 3 times 5? 3 times 5
3 times 5.
is what? 15. And then you have a 0, right? So you're going to have 150 now divided by 2. What is 150 divided by 2?
75.
Outside. What is 150 divided by 2? Yes, Jeremiah.
75.
Thank you. What is our units, class? Centimeters and squared. Thank you. So the space inside of this trapezoid is centimeters squared, 75 of them. All right, we're going to go to 133. And we're going to do some examples. Example number 1. Example number 1 is we are going to have to find the area of a trapezoid. I said a trapezoid, a parallelogram. We'll do a parallelogram first. This parallelogram, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 4, 6, 8. Remember, once again, this is not drawn to scale. On this one, I'm going to tell you we've got 14 centimeters here, 19 centimeters here, now, when you look at a shape like this parallelogram in a test question or in practice, sometimes you're going to get more information than you need. Now, if I were to be finding the perimeter, I would be adding this 19, assuming this is 19 as well, add those together, I'd have 14 and I'd have 14 here, because this is my parallelogram. I could add them all together and I could get what the perimeter is. But what I want us to find is the area, and remember the area is the base times the height. So the height could be in here, where I connect this vertex and this base together and create a right angle, and I could measure it and say that that's 11. But sometimes they actually will throw that information outside of the parallelogram and show you that this is what that distance is. So either it works and it's fine, it's just sometimes they write it in different places. So be prepared for that. So, we're going to do area. Area is the base. What is our base length in this example?
Centimeters?
That is the unit. I want to know the length of the base. Rebecca? 19 centimeters. Good. So we're going to do 19 times the height. What is the height in this example? Lily?
14 centimeters.
They're trying to trick you there. Remember, you want that. Is this a 90 degree? It's not creating this perpendicular line. So you want not a diagonal line, you want a perpendicular line. So what would the perpendicular line be?
11 centimeters.
11 centimeters. They'll do that a lot. So they do it, it is tricky. So just make sure it has to be a perpendicular line. Okay? Good. So we have 19 times 11. If I do 19 times 11, I'm going to get 1 times 9, class. What is that?
9.
1 times 1?
1.
Placeholder. 1 times 9?
9.
1 times 1?
1.
Add it. I get 9.
Oh.
So 209. So our area would be 209 centimeters squared. Okay? Now let's do example number 2, which is going to be our trapezoid. For this trapezoid, I'm going to create a kind of different shape of a trapezoid. And I want to prove to you, so trapezoids, like I said, as long as you have two parallel lines, it doesn't matter really the shape of the other ones. And remember, those two parallel lines are going to be your base 1 and your base 2. So in this case, this line is parallel to this line. So those are our base 1 and base 2. My height, I'm going to put it right here. Remembering that my height has to connect base 1 and base 2 in a perpendicular line. And now we're going to use our formula, which is base 1 plus base 2 times the height divided by 2. So base 1 and base 2 are here. So we're going to plug in 6 plus 8 times the height. Brooke, what's the height? It's the line that's connecting base 1 and base 2. 7.3. Good. Okay. And I'm going to divide that by 2. Following order of operations, 6 plus 8 is what class? Class? 14. Multiply that by 7.3. Divide by 2. I'm going to do my 14 times 7.3 here. 3 times 4 is what class?
12.
Carry the 1. 3 times 1?
3.
Plus 1?
4.
Placeholder. 7 times 4?
28.
28. Carry the 2. 7 times 1?
7.
7 plus 2?
9.
9. Add it up. 2. Don't move. 2. Carry the 1. 10. We have 1 placeholder here. We're going to put that in. So now we have area equals 102.2 divided by 2. If I divide this by 2, I'm going to get 2 goes into 10 5 times. 2 goes into 2